So now let's take a look at how we can prove the angle sum theorem with the two-column proof. So first of all, remember, we're always going to write down what's given, and what we have is we have that AD is parallel to CB, and that's given. And those should never be left blank, even if you can do nothing else. And then the other part that we're going to put in here is that measure of angle 1 plus measure of angle 2 plus measure of angle 3 equals 180. And the nice thing is that we've got a couple things in here to help us. The bad part is my picture's not as good as yours, but it'll work. And we've got a little hint here on part 2, which says alternate interior angles are congruent. Well, let's go back and look at what we've got here. Angle 4 and angle 1 are alternate interior angles. Because, again, notice that AD, this line here, is parallel to CB, this line here. So in between the angles and on opposite sides of that transversal being here, we've got alternate interior angles. So we can say that the measure of angle 1 is congruent to the measure of angle 4. And not only that, but the same thing happens with a different transversal here. This transversal, two parallel lines cut by a transversal, then alternate interior angles are equal. So we can also say that the measure of angle 2 is congruent to the measure of angle 5. Again, still nice because we've got a couple of other pieces of information here in step 3. It says measure of angle 1 equals measure of angle 4. Measure of angle 2 equals the measure of angle 5. So we've gone from congruence, and now we say equal, and we can fill that in here. And what it is definition of congruence, or you can say that congruent angles have equal measures. So next, we're going to take angle 4 plus angle 3 plus angle 5. Angle 4 plus angle 3 plus angle 5. And look what I just wrote in. I wrote in that protractor, and, angle 4 plus angle 3 plus angle 5 equals the measure of angle EAD. And what we did is we took those angles and we added them together, so we can say that we used the angle addition postulate I'll abbreviate the postulate. And next, now we're looking at angle EAD. So angle EAD is a straight angle. And our reason is definition of straight angle. Well, if we have a straight angle, what we can fill in next is, well, how many degrees is a straight angle? So we can say that the measure of angle EAD equals 180 degrees. And that's because straight angles equal 180 degrees. So now, we've got measure of angle 4 plus measure of angle 3 plus measure of angle 5 equals the measure of angle EAD. And now that we know that the measure of angle EAD equals 180 degrees, and what we can say is that the measure of angle 4 measure of angle 4 plus the measure of angle 3 plus the measure of angle 5 equals 180 degrees. And what we did is we replaced the measure of angle EAD with 180 degrees, which is the substitution property. And finally, that leads us to our final step. The measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180. Well, notice, I did pretty well writing right on top of this. We had measure of angle 4, it turned into the measure of angle 1. And that's because the measure of angle 1 equals the measure of angle 4. And I've got it written here in a little bit different order. The measure of angle 3s, they're not right on top of each other, but we've got a purple measure of angle 3, we've got a black measure of angle 3. And then we've got, instead of measure of angle 5 from the purple, we turned it into the measure of angle 2 in black. And once again, what we did is we used the substitution property. And I want to just clarify here to finish. Again, back in step 2, or back in step 3, measure of angle 1 equals measure of angle 4. So we replaced measure of angle 4 with measure of angle 1. The measure of angle 3s from 7 to 8, they stayed the same, but then we've got the purple measure of angle 5, and we've got the black measure of angle 2. And again, if you go back to step 3, measure of angle 2 equals measure of angle 5. So we replaced the measure of angle 5 with the measure of angle 2, and we ended up, because we replaced, we used the substitution property.